Have you ever felt like exams are just a total mystery box? I mean, you pour all your hard work into your answers, slide them in, and then a grade comes out. But what happens in between can feel like some kind of dark art. Well, today, we're pulling back the curtain. We're going to demystify that whole process by cracking open a real GCSE chemistry mark scheme to understand the secret language that examiners are actually using. So here's our game plan for today. We'll kick things off with the exam mystery. Then we'll get into decoding the playbook. After that, we'll see a question in action. Look beyond right and wrong. And finally, we'll talk about your exam superpower. You know, every exam really comes down to two documents. The first one, you know it well, maybe a little too well, the question paper. But it's the second one, the mark scheme, that really decides your fate. So the big question is, how do you get from one to the other? Okay, so look at this. On the left, that's your world, right? A question paper filled with all sorts of challenges. But on the right, that's the examiner's secret weapon, the mark scheme. And trust me, this thing is way more than just a simple answer key. It's a super detailed guide. So how on earth does an examiner use this thing to turn your writing into marks? Well, that's the very code we are about to crack. So before an examiner even glances at a single student answer, they have to study a really detailed set of instructions. This is their playbook. And understanding these secret rules, that's the absolute first step to mastering your exam technique. Let's start with a word that's actually your friend, allow. When you see this, it means there's more than one right way to say something. For example, you know that classic test for hydrogen gas? The textbook answer is a squeaky pop sound, but the mark scheme allows just pops. So it gives the examiner a bit of wiggle room to give you credit when your answer is still scientifically on the money. And now for the opposite. Do not accept. This one is a big flashing warning sign. It's a hard rule. An answer here is just plain wrong. For that same hydrogen test, the mark scheme is crystal clear. Do not accept glowing splint. And why is that? Well, because that's the test for oxygen. Mentioning it shows you've mixed up something pretty fundamental, so it's an instant no-go for the marks. This brings us to probably the single most important principle, and this is taken word for word from the official guidance: right plus wrong equals wrong. This is a total game changer. It means if you write down a perfect answer and then add a little something extra that's incorrect, that wrong bit can actually cancel out your right bit, leaving you with 0. It's a huge warning against trying to hedge your bets. You've got to be confident and precise. And it's not just the words, even the formatting is part of the code. If you see a word that's underlined in the mark scheme, it is absolutely essential. You have to include it to get the point, no exceptions. And if you see a bolded and, that means you need to give 2 different bits of information to get that 1 mark. If you miss one of them, you don't get the mark. Simple as that. All right, enough theory. We've decoded the playbook. Now it's time to actually put ourselves in the examiner's shoes and see exactly how these rules work with a real question from the paper. Okay, here we go. Question 01.4, worth a nice 2 marks. This is a classic. Part 1 wants the test, Part 2 wants the result. Seems pretty straightforward, right? Well, let's see how those 2 marks are actually given out. And here is the breakdown. The question is split into 2 marking points, or MPs. For the first one, MP1, the test, you need to say burning or lit splint. And look, there are our friends allow and do not accept right there in the notes. For MP2, the result, you need burns with a squeaky pop sound. But check out this crucial detail. MP2 is dependent upon MP1. What that means is you cannot get the second mark for the result if you got the first part about the test wrong. The whole answer has to be logical. Okay, so that covers a knowledge question. But I know what you're thinking. What about those dreaded calculation questions? It's a huge fear for so many people. If my final number is wrong, have I just lost all 3 marks? Absolutely not. And this right here is why showing your work is a genuine superpower. Calculation questions are marked in stages. You get marks for the method, even if the final answer is a bit off. See that little note, error carried forward, or ECF? That means if you make a tiny mistake in step 1, but you use that wrong number correctly in step 2, you can still get the mark for step 2. So please, I'm begging you, always show your work. So far, we've been looking at questions with really clear tick box marking points. But what about those monster 6-mark questions that ask you to plan a method or evaluate something? Well, this is where marking gets a whole lot more interesting. Okay, let's look at this new question. You're being asked to plan out a practical method to identify 2 different ions. Now, for a question like this, the examiner isn't just hunting for keywords. They're actually judging your ability to think like a scientist and put together a plan that's logical and that would actually work. To help the marker out, the mark scheme gives them what's called indicative content. Now, this is not a perfect answer you need to memorize. Think of it more like a checklist of the key scientific ideas the examiner is hoping to see, things like the flame test and the precipitation test. But, and this is a big but, just listing these points is not going to get you the top marks. And this is the crucial difference. These big questions are marked in levels. A level 1 answer, that's going to get you 1 or 2 marks, might name a few correct steps, but maybe they're jumbled up so the method just wouldn't work. But a top-tier level 3 answer, the one that gets you 5 or 6 marks, has all the key steps in a logical sequence. It describes a method that would actually work in a lab. So the structure and the logic are just as important as the facts themselves. So hopefully by now you can see that using mark schemes when you revise, it isn't cheating. Not at all. It's about understanding the rules of the game you're playing. It's about learning to think like the very person who's going to be marking your paper. And that knowledge, that's your exam's superpower. Okay, takeaway number 1. Think like an examiner. You have to use the specific language they're looking for. Don't just write, "a splint makes a noise." No, the mark scheme wants a lit splint that burns with a squeaky pop. Using that exact terminology tells them you really know your stuff. Takeaway number 2, structure is everything, especially for those big mark questions. You have to avoid the brain dump, just throwing everything you know on the page. Think step by step. Guide the examiner through your logic from beginning to end. A clear, structured answer is an absolute gift to mark. And our final takeaway, never, ever leave a calculation question blank. Those method marks are precious, and they're just sitting there waiting for you. Show every single step of your work, because even if you have a little slip up along the way, you can still walk away with a fantastic score. So there you have it. You've had a peek inside the examiner's playbook. You now know that it's not just about what you know, but about how you present it according to their rules. You know the secret rules of the game, so the only question left is, how is this going to change the way you revise?